We're still going to be talking about analyzing graphs of polynomial functions. So this is still in section 5-4 of your textbook. Um, I'm just going to do a few examples that are going to be similar to some of the homework problems you do. These are on page 335. So the first one on problem 27 says to sketch the graph of a polynomial function with the following characteristics. So we want to sketch a graph of an odd function. So think about what that means. And actually, let's say odd degree function. This actually is, to talk about odd or even functions, has a different meaning. In class, we talked about how this was an odd degree function, so the textbook should have said that. The same thing on this should have said an even degree function with zeros, and it gives us a list of zeros. So if we wanted to graph this, now notice it says sketch the graph of a polynomial function. So there could be multiple types of polynomial functions that have this. So, but we're going to sketch with these zeros. So the first thing I'm going to do is mark the zeros. I'm going to count by ones. And if I mark the zeros at -5, -3, 0, 2, and 4. So I'm told that these are the zeros, and that's really all I'm told, and I'm told that I have an odd degree function. I'm not told if it's an even, if the leading coefficient is positive or negative. I'm not told that. I'm not told anything about maxes or mins. All I know is I need to draw an odd degree function, which means when I graph this, remember one end has to be up and one end has to be down. Again, because I'm not told it's negative or positive, that part doesn't matter. Don't know about mins or maxes. So I'm just going to draw. That was very bad. That didn't look too polynomial-like. So that's a possible polynomial function. I mean, this would be smooth and kind of hard to do here, but that would satisfy this requirement. So notice the one that I drew was a 5th degree polynomial, so because I had 5 zeros. All right, so next one. Sketch the graph of a 4th degree function. So that tells you something about the end behavior, either both ends up or both ends down, with a 0 at -3. So I'm going to plot a 0 at -3. Again, I'm counting by 1, so I'll scale my graph. A maximum at x equals 2. So it doesn't tell me what the maximum is. I don't know how high up it's going to go. I just know it occurs at x equals 2. So I'm just going to place it right here. And a minimum at x equals -1. So I'm just going to place it right here. So I'm going to say that this is my max and this is my min. Again, I don't really know how high up or far down I go because they don't tell me that. They just tell me to draw one that would have maxes and mins there. Has to be a 4th degree function. So if I start at the bottom, then I'm going to have to end at the bottom because remember we have to have a either both ends up, both ends down. Now these have to be, one of these at least has to be relative and not absolute. We weren't told that they were relative or absolute. So I'm going to draw it like this. This has to be a minimum, so I'm going to draw it like this. Okay, so I have a 0 at -3. Notice that in order to go from this this min and this max, there has to be another 0. So even though they told me there was a 0 there, they weren't indicating that it was the only 0. So this would satisfy that. So on this next one, we're going to draw a graph of an odd function. So that should tell you, even as you read that, or actually let's change this, odd degree function. And when you do this one, this should be even degree function. So when we do that, we know that one ends up, one ends down, with zeros at -1, 2, and 5. So when they tell me the zeros, I'm going to plot those right away. So -1, 2, and 5. They're giving me the x value for when we have a 0. Remember, the 0 of the function is when y equals 0. And a negative leading coefficient, the fact that they tell me the leading coefficient is negative, I've got 3 zeros, so I'm probably going to draw this in as a cubic function. So remember, for that means that it's going to be something like this, if it's a negative leading coefficient. So that means it's going to do, and I don't have anything about maxes or mins, so I can make up how I want to. So I'm going to draw it like this. And that would be an odd degree function. So I've drawn it as a cubic. I've got the zeros that they have set for me and a negative leading coefficient, which means the left end behavior is up and the right end behavior is down. So that's how you're going to do the graphs. You'll be doing 28, 30, and 32. Then this next set of problems, they give you the graph. You have to estimate the x-coordinate. So here's number 35. Estimate the x-coordinate of every turning point and determine if those coordinates are relative maxima or relative minima. So notice that they say estimate the x-coordinate. So they're not having you do an ordered pair. You could in other situations. It's just that these are what these directions say, the x-coordinate. So we have notice that we have minimums. So I'm going to say relative minimums at, and it looks like it's about x equals, assuming that we're counting by ones, and they didn't tell us that, they should have. It looks like maybe about negative 2.5 and x equals 1.5. Okay, so we're just estimating where those would. Now notice that these are also absolute mins. Now if you were asked what's the minimum value of the function, assuming this is counting by ones, it would be negative 3. So negative 3 is the minimum value of the function, assuming scaled by ones. Now, that's not what they're asking you, so you don't necessarily have to state that, although we're going to use that in the domain and range. So, but just be aware of the difference between how you might be asked about the minimum and maximum. If you're asked the minimum value of the function, it's the y value. But here, because of the directions, we'll follow that. So then there is a relative max at x equals, and that looks about to be negative 0.5. And notice that there is no absolute max. So that's part A. Part B says estimate the x-coordinate of every zero. So the zeros are at x equals 1, 2, 3, about negative 3.8. About, well, it looks like negative 1, 0, and 1, 2, 3.2 maybe, because you're estimating. Part C, determine the smallest possible degree of the function. So notice I have 3 turning points. So the smallest possible degree of the function would be a 4th degree. But remember that it's possible, also we have 4 zeros, it's possible that it could be a 6th degree or an 8th degree, but this is the smallest it could be. And part D, the domain and range. Domain, all real numbers for polynomial functions. The range, there's an absolute min, and we decided that was negative 3, counting by ones, so we're going to say y is greater than or equal to negative 3. For problem 37, part A, estimate the x-coordinate of every turning point and determine if it's a relative max or relative min. So turning points we have at x equals, again, I'm going to assume that we're counting by ones. So maybe negative 3.5. This would be a relative min. And we have negative 1.8. Again, a relative min. And 1, a relative min. So that looks like all the minimums. And then notice at about negative 2.5, we have a relative max. At negative 1, we have a relative max. That looks like the relative max. Notice that this x equals 1 is also an absolute min, okay, because there's nothing lower than that. That's going to help for the range. So those would be our, for part A. For part B, the zeros, we've got at about x equals negative, let's see, this is -4, this is -3. So we have about -3.7 and another one at about -3.2. We're just estimating these. Another one at about -1.9, maybe negative, what I call the zero, -1.8. So let's call this -1.7. Another one at about -0.2, and another one it looks like at 3. So 1, 2, 3, 4, 5, 6, looks like 6 zeros. Determine the smallest possible degree of the function. Well, that would be 6. Determine the domain and range. The domain, all real numbers, and the range. Remember I said that the absolute min was x equals 1. And that, well, that's the x value, but look at the y value, 1, 2, 3, 4, 5, about -5. Y is greater than or equal to -5. Okay, so for the last one, number 39, if we are looking at the x-coordinate of every turning point, so let's say we've got x, again, counting by 1, so 1, 2, turning points at -2, and that looks like it is a relative max. And at x equals 1, it looks like we have a relative min, and that's it. No absolutes. Part B, the zeros. It looks like we have a 0 at about -2.9. I can see it's not really -3, pretty close though. And about -0.8, we'll call it, and about 2.2. Again, assuming that they're counting by ones. So those are our zeros. The smallest possible degree would be a 3rd degree. The domain, again, all real numbers. The range, notice one end up, one end down, all real numbers. So that should be all you need to get through your assignment for today. If you have any questions, you can send me an email and let me know.